Hey everyone, in this video I'm going to teach you about social network analysis in R. Now this video is going to assume that you already have some kind of core working knowledge of R, that you know about things like data frames and vectors, and that you've done a little bit of data wrangling or data cleaning and reshaping and restructuring. I'm going to focus mostly on the technical side of things, how to write code to create networks and analyze networks. And if you're interested in more of the theoretical, ideas about social networks, how they shape human behavior, and so on, you can check out some of my other videos. Or if you lack those kind of basic skills in coding, you can check out my earlier tutorials on introducing data wrangling, R and RStudio, and so on. Okay. So as you can see, I prepared for you today two .r data files. The first one is called Senator Profiles. And as I open this up, we'll see that what this is a list of senators. Here's their names and their state, their gender, their ethnicity, a few other things, but also their Twitter information. So their Twitter screen name, which refers to their Twitter handle, and their Twitter user ID here, and then we've also got some information about the number of followers they have here. So in today's tutorial, we're going to try to plot the social network of senators. There's 100 US senators, and we're going to try to look at how they, whether they follow each other on Twitter or not, as a simple kind of toy example to get us started. Okay, so you'll notice that I have two data sets, not one, and that's a little confusing. Typically when we're doing an analysis, we're used to running it on one data set, but social networks are a little different. Typically we need two types of data sets to build a social network. We need one that contains information about the nodes, maybe the individual people or whatever other social unit you want to study is. In this case, it's senators. And so this data set here is kind of like a list of our nodes, the people who we want to connect to each other. And then in this data set, we also have node attributes. So we know the gender of each node, or we know the number of followers of each node. We also have this ID here. This is Twitter's ID that it assigns to each person. And this is going to be useful because it's going to help us understand the other data set we've got here. So in this data set, we have what's called an edge list. This describes who's connected to who. Edge lists typically have only 2 columns, sometimes 3 columns. And what they describe is who, in this case, is following who on Twitter. So this is one senator in our senator data here, and this is another senator. And so as we scroll down, you can see we've got one person connected to another person, one person connected to another person, all the way down through all of the senators. And there's 4,906 connections between the senators. So this is a pretty big file. Now, usually I mentioned there's only 2 columns. There could be more columns in a network data set if there are edge or ties. We use the words edge and tie interchangeably a lot in network analysis. If there's attributes about the edge, just like there's attributes about the nodes. So maybe we know the gender or the number of followers of the nodes, but with edges, maybe we could measure the strength of the tie between people somehow, or maybe it's a dynamic edge which comes in and out over time, and maybe we want to add some timestamps to our edge list here to kind of allow us to visualize a dynamic network. We're not going to do that today. We're sticking to a kind of simple example, but I just wanted you to know a little bit about how nodes and edges look. Again, you need 2 different types of data sets, one that describes the nodes or units that you want to connect in your social network analysis, and the second is the edges or the ties between them. Now, we're going to work with a package in R called iGraph. This is a kind of an indispensable package for network analysis in R. It does a lot of different things. It can create what's known as a network object that kind of combines our nodes and our edges into a single type of data structure. And there's many different ways that we might begin working with network data. This is a pretty well prepared example, and I like to work through messy examples in these tutorials so that you get some idea of what to do when you run into kind of issues. But to give you some background, it took me about an hour to prepare these data, to collect them from Twitter, to clean them, to restructure them and rename them so that it was a little bit easier for you to follow. So if you're working again from scratch, you may need to go back and consult some of my earlier videos on data wrangling if you want to prepare the data exactly as I have here. Okay, so let's go ahead and start bringing our node list, this senator profile here, and the Senate networks data together into a single iGraph object or network object. To do that, we're going to use a function within the iGraph package that I've now loaded here that's called graph from data frame. And basically this is going to require two inputs. First, it requires a data set of the edges, which for some reason is abbreviated D, which I find a little confusing, honestly. And ours is called network senate. If you look over here, you can see the name of the file is a little different than the name of the object or data frame is a little bit different than the name of the file here. Of course, I spelled it wrong. And next we need to specify the vertices. Now there's just so much jargon in social network analysis, and this is really unfortunate, but vertex is another word for a node. So a list of vertices is just the list of nodes. So I'm going to go ahead and describe our vertices as in our senator data object here. And lastly, iGraph is going to want to know if your graph is directed or not. So network data can contain information about, in this case, who's following who, right? One senator following another senator. You could think of there being an arrow in that relationship, right? One person follows another person. And that's what we call a directed network. Or network data sometimes simply contains information that two people are connected without any information about who initiated the contact or in this case, the following. And so that would be a undirected network. So if we have information about who's following who, and typically we make that assumption when we read in data in iGraph, then we would write, as I've done here, directed equals true. Now I also need to give our object, our network object, a name. I'm going to call ours Senate_net. All right, let's take a look at that. All right, so you can see here we've created a new object. If you click to browse here, you can see it's a little bit complicated. It's actually some lists with both attributes of nodes and the edges. And so what iGraph is really doing for us here is kind of keeping track of a lot of different parts of the network that we're building here. Now, we can kind of browse the object as we could in any other object in R, and we can see here that it has taken those user IDs and replaced them with the name variable. So here we see which senator is following which other senator. And so that's kind of useful. There's some kind of strange stuff about the way that you work with iGraph objects. So we might like them to have a kind of data frame property where we could just kind of write name like that and see the name of each vertex or node in the data. Unfortunately, to do that in iGraph, we have to use a somewhat unusual syntax, which is to wrap the name of the object in capital V, for which stands for vertex, and then we can access the attributes through our atomic operator here, the $sign here. And so now you can see the names of all the people in the data frame. We've got some other variables. You may remember we've got their political party, we've got their gender, and so we can kind of browse through our data this way. Now that's how we look at the vertices. If we wanted to look at the edges or ties between the senators, we could write E SenateNet, and this is shorthand for edges. And if we had attributes for the edges, we don't. For example, if we had a weight that described how strongly people were connected to each other, we could write in weight here, but we don't now. Okay, so that's just to show you how to browse a iGraph data frame. Very often when people are reading in their data for the first time, they have some kind of data aggregation cleaning error, and they think the data looks one way, but it doesn't, and it can be kind of hard to look at the iGraph data. So as always, I encourage you to browse your data before you charge into more sophisticated analyses. Now, iGraph has some plotting functions within it. It has a function called plot. Now, we can try this, but I promise it's going to be ugly. I'm just going to save our file here. Okay, I've gotten a figure margins too long error. That just means that my viewing pane here is not big enough to plot the network. And now you can see R is starting to work with this stop sign here. And there you have it. what we like to call the hairball network in R, right? We're not going to make much sense of this thing. The label here, you can kind of see there's some nodes up here, and these arrows are describing the edges between people, but mostly we're just seeing a collection of messy node labels, the names of the people attached to each node. So that's not great. We could go deep into iGraph's plotting functions and clean this up. We can actually go really far. It's a pretty powerful graphics library. We can control all sorts of aesthetics. But given that many of you will already know ggplot, I'm going to instead introduce you to another package, which is kind of like ggplot for networks, and that's called ggraph. So as I install it here, I'll just go on to kind of say that it's very similar to ggplot in that we can kind of add layers to a plot. So what we're going to do is we're going to call a kind of core function called ggraph. We're going to pass our network object. Ours is called Senet_net to that object. And then we're going to layer on nodes, and then we're going to layer on edges. So I have to load the library here, ggraph. And now let's just try out a simple network. First, let's try just plotting the, let's do just a very simple plot of the nodes. So in gggraph, just like in ggraph, sorry, just like in ggplot, I add layers with this addition sign here, and I have to make sure that I have these addition signs at the end of every line except for the last line, otherwise I'll get errors. And so I can add in the nodes using this geom_node_point. So in an earlier tutorial on data visualization, I described how you could create a bar graph with a function called geom_bar. Same thing here, we're just layering on different parts of the graph. So here we can add on geom edge link, that's going to add our edges, and I'll just go ahead and run that so you can kind of see a little bit what it looks like here. It's chosen a stress layout as the default layout. Layout refers to the position of each node in Cartesian space, so where they are appearing on the plot. Now, as you can see here, we've got another ugly plot. We're going to make this prettier, I promise. But what you see here is that we can use different kinds of layouts, and those will arrange the nodes in different ways. Typically, we can let ggraph choose for us. It's going to try to choose the layout that lets us see the most information. But just so you know, there's tons of different ways of arranging networks into layouts, dozens and dozens of algorithms that can do this, and you can specify those using a argument called layout here in ggraph. Okay, so that's pretty ugly. We've got a kind of funky background there. We could add a theme void to try to clean that up a little bit, but it's still going to be a pretty big hairball. So what we probably want to do to start off is just begin with some aesthetics so we can start to see some of the structure a little better. So one thing, for example, is the width of these edges, the ties between the nodes, is really, really thick, and that's kind of making this massive hairball Death Star that we see on the screen right here. So I can add in a parameter like width. I'll go ahead and do, let's say, width equals 0.05, and as we wait for it to load up here, we should see that the edges, the links between the nodes, are now a little bit smaller. They're not really much smaller, but let's add in some other aesthetics here. Oh, oops, sorry. That's because I added it to the nodes instead of the edges. All right, let's try that again. Okay, what else could we do? Well, we could also begin to try to extract more information from this graph by maybe overlaying some of the attributes of the nodes that we know about. There we go, that looks better. So for example, now we're starting to see some of the structure. We can kind of see two groups here, which isn't super surprising. It's probably the Democratic senators and the Republican senators. But let's try to pursue that intuition a little more by adding some aesthetics to the nodes themselves. So let's try to color the nodes by the party of the senators themselves. So I'm going to add an aesthetic argument here, just like in ggplot, where I'm trying to specify a particular variable to use to color something, as I might do in the aesthetics argument in the main kind of ggplot. And now I'm adding color using our party variable. Our party variable was part of our original senator kind of profile data. Okay, so now we can see it is hilariously labeled Democrats in red and Republicans in blue. That's real convenient. The reason it's done that is because of alphabetical order, oddly enough. So we could go back and fix that by adding some scale color gradients in ggplot, but for now, let's not worry about it too much. Our nodes are still really small. Another way we could improve this visualization perhaps is to resize each of these nodes according to, say, the number of followers they have. So we can come in here and I'll add, in addition to party, I'll add size equals followers count, which is another variable I created in this data frame I produced for you here in order for you to kind of take a look at different attributes of the network. So what we should see now is each node resize so that people with a lot of followers appear bigger in the graph and people with few followers appear smaller in the graph. And now here we do see some bigger names, more prominent people on Twitter anyways, pulling up here. We've got some independents here, and we're still seeing that kind of color structure. So the next thing we might want to do is obviously figure out who these people are. Who's this green person who's got a lot of followers and is an independent? Well, you may have some guesses, but let's go ahead and try to add on or layer on some node labels. So to do that, I'm going to add a function called geom_node_text, and that's going to add on the names, provided that I give it the name of the variable that contains the names, which in our case is just called name. So we can try this out. Typically when we layer on names, it creates a bit of a mess because the names can be really big, or maybe they overlap some of the ties and edges, and we'll work through it carefully to try to prevent that from happening. But yeah, look at this. Lovely, right? So if we blow this up, we can begin to see who's who. It's still pretty ugly. It looks like that big green node there was Bernie Sanders, but we can't really make sense of any of this. So we can do a few things. We could, for example, change the size, so we could make these smaller. And I'm also going to add a something called repel, which is an option that kind of rearranges the labels so that they try not to overlap other objects in the graph. So let's try that out, see if we can make this a little bit prettier. Once again, it's using a default layout here. It's taking a moment for it to come up here in my RStudio. But now this looks a little more reasonable, right? We've still got some aesthetic issues. It's really hard to make sense of who's who in here. I'll show you some tips about that later. But at least we're starting to be able to make sense of who these big name people are: Rand Paul, Bernie Sanders, Kamala Harris, and so on and so forth. So good, not great. We've got some labels here. We are by default just going to use scientific notation to render those labels. We'd have to go into some theme elements within the gggraph or ggplot kind of library to clean those up. So we still have more work to do, but at least hopefully by now you're getting a sense of how to begin to work with and visualize network data in R. So far we've focused on creating network objects and visualizing them. But very often, one of the things we are most interested in doing in network analysis is doing some type of actual measurement of the graph. So for example, we might be interested to identify the betweenness centrality of each person in this graph. And basically what that means is the people who kind of connect the whole network, if you will. The people for whom most people have to go through to realize a connection to everyone else in the network. So you can think of these people as kind of sort of similar to network brokers, or people who maybe are exposed to different kinds of information in a network and therefore may be more likely to either spread that information, and if it was, say, information about a job opportunity, that could be great, but maybe on the other hand, it's a virus spreading through the network, and then you wouldn't want to be the person with high betweenness centrality. So betweenness centrality is going to be a metric. When it's higher, it means the person is positioned between multiple clusters in the network. Now, we don't have very visible clusters in this network. Typically, we see a little more clustering. I think what we're seeing here is that a lot of US senators follow a lot of other US senators. So we'll calculate it and then try to make sense of it a little bit later. To calculate betweenness centrality in iGraph, we use the betweenness function, and we simply pass the name of the network object into this betweenness function. And now what we've got here is some output with each person, so we can see who's really, high up here. Looks like Tim Scott. Who else? Kirsten Gillibrand. So a lot of prominent people, which isn't super surprising. Maybe some independents have higher or lower scores depending on where they are in the graph. Okay. So again, we could calculate a lot of different other kinds of metrics. We could calculate closeness centrality. We could calculate eigenvector centrality. There's all sorts of different ways of measuring position within a network. But suppose we want to resize our graph now so that the size of the nodes is not the number of followers, but the betweenness centrality. Because it could be that having a lot of followers is great, but if most of these followers are only from your home state, you might not actually have much influence. It might be better to be connected to more diverse pockets of senators if you want to, say, spread an idea or a message in this network of senators. Even if Twitter is maybe not the right place for policy deliberation. Well, we can come in here and we could simply, this is another example of in R how we can often put functions within functions, and that can make the code kind of difficult to read, but it's also really convenient. So I could just, for example, write in here betweenness Senate net right here within my size argument and run this. And now what we should see is each node will be sized according to its betweenness centrality. So we should be able to see, is Bernie Sanders, who was who had a lot of followers in that first graph, is he also kind of influential in this Senate network? And now what we see is actually Bernie Sanders is really at the edge, probably because he's mostly connected to just the liberal cluster, which is again hilariously pictured in red here. And we see it's more like people like John Corbin, Tim Scott that have high betweenness centrality. Again, this is a pretty messy graph. We'd want to clean it up in many different ways, maybe try some different layouts to see if we can pull out some of the structure a little more meaningfully. But again, this is just an example of how you can begin to incorporate some of the network metrics into data visualization. Okay, now another kind of interesting question that we can look at with network analysis is something called community membership, or community detection. And what this really means is we try to kind of group nodes according to patterns in who they're connected to. So you could kind of think of it as if this was a network of students in high school. We could try to find the cliques, who's connected to who, and try to pull out some information about, kind of what the core communities are in a group of people. Now here it seems pretty clear there's two, right? It seems like there's Democrats and Republicans, but let's try to test that intuition a little more empirically by doing some community detection on our data. So first we have to choose a community detection algorithm. There's a lot of them in iGraph. A lot of these are called cluster. I'm going to use one called cluster walk trap. I'm going to create a new object out of that. And this is going to create a list style object. From that list style object, I can ask for the membership of these people. So then I can see, okay, well, some people have been assigned to group 1, some people have been assigned to group 2. And again, these assignments are being made according to who they follow. So if they follow the same types of people, then they go in the same type of group. Now, this is a little tricky because I need to create a new attribute which will equal this membership in our data. So the way I'm going to do that, there's a few different ways I could do it, but I'm going to actually add a new attribute onto our pre-existing object here. So I'm going to add a node attribute that's going to be called community. And I can simply write the name of the new variable here and give it these values here. And now, instead of using party to be our color, try using community here. And let's try to replot this and see if we get a similar outcome. So what we're seeing here is if the party labels are going to map on to the community detection analysis we're doing right now. So if we see the same kind of two groups popping up as Democrat and Republican, we can be pretty sure that it is kind of party that's driving it. Now it's a little bit hard to see in this graph because we've got a color gradient here. It might have been wiser to simply get assigned kind of a wider palette so the colors would pop a little bit more. But what we're seeing here is that most of the people seem to be in this kind of what I might call a center-left cluster, and then there seems to be a kind of center-right cluster up here. So we'd want to go a little deeper into this, maybe visualize it a little better to make sense of it. But again, this is kind of a proof of concept of how you can begin to work with different network metrics and add them to your visualizations. All right, now these are all static visualizations. Another area where R really excels is in interactive network visualization, thanks to a lot of new packages. One of the ones that I really like is called Network D3. I'm going to go ahead and install that. And while that's installing, I'm also going to get ready to load it here. And one tricky thing about some of these interactive visualizations is they often require a different data structure. So maybe, for example, instead of having a data frame, you have to have your data in JSON format, which is a very different kind of format that we typically work with to move files around the web, especially. So there's some interesting kind of solutions to that. You can get into restructuring your data, and that's probably a good skill to practice. But there's also some nice helper functions or functions that kind of help you look at different parts of your graph and transform them into kind of more easier to use objects. So let's see what it's called here. I think it's called iGraph2 Network D3. So this function is going to take our Senate net object and then create a new type of data structure that we need to produce a interactive visualization. Now, one problem with interactive visualizations, this is a pretty complex network we've got. We've got 4,900 and change edges. So that's a lot to move around in an interactive visualization. So what I might do before we move to this visualization is just take maybe half of our network and try to plot it. So before I get into Network D3, I'm going to use a little bit more, I'm going to create a new object called SmallNet, and I'm going to use a function in iGraph called induced subgraph. Subgraph is kind of like subsetting a graph or taking a small slice of a graph. And let's take our Senate network, but let's only look at the first 20 people. Okay, so now we've got a much smaller network. And now I'm going to pass that to our iGraph to Network D3 function. So what we need to do now is kind of think about how we want to visualize this. We could just pass the function and create, interactive net object. But if we want to visualize things like the party of the people in the network, we're going to need to also communicate where that information lives. This is going to get a little tricky because we have to once again use our clunky iGraph notation. So I need to use v smaller for the vertices of the smaller network that we just created up here. That's actually called SmallNet. And then I'm going to go ahead and grab the party variable, which contains the information about whether people are Republicans or Democrats. And then lastly, it's going to ask me if I want to create both node lists and edge lists or just one, and I want both because I want to create something called a forced network. So I'll go ahead and try this. It looks like we've got a new object here. And now one of the kind of workhorse functions in the Network D3 package is called force network, and that can produce a network that allows us to interact with it with our mouse, which is really useful if particularly if we've got a really dense network. Now this function has some kind of complex syntax. There's a lot of different arguments that go into it. So if you don't know it by heart, don't worry at all. You can always just look this up. You could Google force network to kind of figure out everything I'm doing here. But first I need to specify where the edges are. They're calling them links, another example of how different things can be described the same way. So mine is actually called interactive net, and it's called links. Then I have nodes, which equal interactive net nodes. And then I also always need to, in this function, pass an ID variable, because when I mouse over any node, it's going to reveal that label. And that's called here node ID. And in our data set, that's called name. And then group always assumes the value of group, because that's what we called it in the function above here when we created our, oops, I forgot to create it actually. Group equals, so I'll go ahead and add that back in. Group equals group. And finally, I'm just going to add this zoom equals true, which allows me to zoom in and out of the network. Let's go ahead and try this. Quite possible I messed up some syntax, but there we go. There we have it. Okay. So now we're mousing over. We're looking at a small chunk of the bigger network that we just made. I'll blow it up so it's a little easier to view here. And I can now zoom in as well. And anytime I mouse over a given node, I can see the name of that person. So here's senators all connected to each other. Once again, we'd love the color to be red and blue, and instead it's light blue and blue here. We'd have to go in and introduce a new color palette as an option in this force network function to do that. But for the time being, we've created a pretty nice way to create interactive network visualizations. You can check out a lot more of them at the Network D3 page. There's also another wonderful library called 3JS, which also has really great interactive network plotting capabilities. So there you have it. That's some kind of basic intro to networks in R and how to work with them, how to create them, how to browse them, how to visualize them, how to analyze them, and then how to produce an interactive network.